together, right? Okay, so we're going to do trig functions. I'm also going to give you these very lovely yellow identity sheets that we're going to be using today and in the next couple chapters. So I have all sorts of good things to give you. So first, we need to just go through and define the trig ratios. Ratio, remember, fancy word for a fraction. You're comparing two sides of a right triangle. So off on the side, I drew my little digital one. Draw yourself a right triangle. Put my little right angle in there. Parker.
I have the right notes back here because this is right.
Yeah, they're sitting right up here on the table, my friend.
Yeah, I think I just grabbed the wrong one.
Should have grabbed that yesterday, but anyhow, okay, so of course our longest side, the side across from the right angle, is our hypotenuse. And then the other two sides, when we look at our SOHCAHTOA, of course, are opposite and adjacent. Now notice I haven't labeled those yet because we have to go off of a specific angle. You can see they're using T here for the angle. You might see X, you might see theta, doesn't matter. I'm just going to pick one of these angles to be T. I'm going to do the bottom one. So then the side straight across from it, of course, we call the opposite, and the side next to it, adjacent. All right, so again, a trig ratio, you are just comparing two sides of the triangle. Sine, what we're used to our SOHCAHTOA over there on the board, compares the opposite side to the hypotenuse. Cosine, SOHCAHTOA, is your adjacent compared to the hypotenuse. And tangent, TOA, that's our opposite over adjacent. I'm assuming this all looks very, very familiar. Okay, hopefully you've done the other three trig functions. They are the reciprocals of sine, cos, and tangent, meaning, and they are paired up in order for a specific reason. The reciprocal of sine is cosecant. So cosecant is hypotenuse over opposite. Cosine, the reciprocal secant. So I'm going to do, of course, hypotenuse over adjacent. So cotan, of course, adjacent hypotenuse. Now, I'm going to add to this too. This might be new to you. So the other thing we're going to take a look at, we talked about them a little bit yesterday, those quadrantal angles, the 90, 180, 270, 360, the ones on the axes. You can't make a triangle for those. We're clearly going to find sine, cos, tan, all of those of them. So I put hypotenuse. I meant to put opposite. Sorry. So one thing I'm also going to add to you, these might be new. I don't know if you've seen these or not. So another way you can get sine, the fraction for sine, you could do 1 over cosecant. To get cosine, you can do 1 over secant. And to get tan, you could do 1 over cotan. Have you seen those black fractions before? Those might be new to you. And I'm not going to bore you with how the fractions work, but like for instance, if I do 1 over cotan, well, cotan, of course, adjacent, opposite. When you divide by a fraction, you end up multiplying by the reciprocal. And we can see that that clearly gives you the sides for tan. So it's just another way to kind of quote unquote manipulate the fractions. So cosecant, you could do 1 over sine. Secant, 1 over cos. And cotan, 1 over tan. Now, you might not have seen those black fractions. I'm just giving them to you for the first time. And just to help the cause, the next thing I'm going to give you is I have these very lovely yellow little identity sheets that has this stuff on it for you. So you got it. So you got a little reference. So let me give everybody one of these. My little card stock there. Nothing but the finest for you guys. All right, I put an extra one for Daniel in your row there. Landon, I'm going to give you one for Parker, okay?
What if I just took it and never used it?
So why did we write this down?
Never passed it back.
All right, pass those back. Abby, I threw some for you guys in this row too. All right, so pass those back. Let's get into it. Now, all of our triangles today are going to turn into our special triangles, our 30, 60, 90s. So I thought you might need a little review on how the sides are labeled on those. So draw yourself 2 right triangles. Clearly, technology had them drawn on here. Let me put my right angle symbol on. Okay. So all of our triangles today, as we're working on these, are going to turn into our special right triangles, our 30, 60, 90. I'm going to do this as my 30. This is my 60. And then I'll make the other one the 45, 45, 90. All right, now back to geometry. Remember, your triangles are what we always say are proportional. Across from the smallest angle is the smallest side. Medium angle, medium side. Biggest angle, biggest side. So across from the smallest angle is your smallest side, which on a 30, 60, 90 is always 1. Opposite the medium angle, your medium side, which is about 1.7. I just happen to know the decimal. And your hypotenuse is 2. So if you remember back to your geometry days, let's say I told you the short side, the short leg, geometry short leg was 5. So 5 square roots of 3, 10. 5 times 2. They're always proportional is how those work. Now, 45, 45, 90s. I just taught kind of isosceles triangles today in geometry. 2 congruent angles, 2 congruent sides. So they're both 1 and 1. They're going to be the same. 10 and 10, 7 and 7, whatever they're going to be. And then you get your hypotenuse. You multiply the side by a square root of 2. Ours today will always be the 1, 1 root 2. And same on the 3, 60, 90. 1, 2 square roots of 3. So hopefully those look a little familiar to you. Of course, you can use your notes today as you're drawing these, but you're going to be drawing so many special right triangles, you will have those memorized. All right, to actually evaluate trig functions. So you're going to sketch the angle just like we did yesterday. Make sure it's in the right quadrant, just like yesterday. We're going to figure out what's key here, the reference angle. It is the angle formed between the terminal side, the side that rotates, and the x-axis. It should be 30, 45, or 60. I'm not going to give you anything that is not 30, 45, or 60. Can you do other angles? Yes, but that's a different section. We have different tools we have to use to figure it out if it's not 30, 60, 45. You're going to make your right triangle with the x-axis. And then, of course, I'm going to label the sides accordingly. If I have my 45, 45, 90, I'm going to label them 1, 1, root 2, so on and so forth. All right, let's do it. So first, mark out 135 degrees, just like you did yesterday. Now, I'm going to get dramatic and do a lot of labeling on the first couple, but I know you've got your 0, your 90, your 180. Okay. I'm not going to do all the labeling every single time. It just gets obnoxious, but just to make sure we get the first couple drawn right. Now, when you draw your angles, especially for those that were done yesterday, vertex on the origin, initial side, positive x. All right, question is, 135, which quadrant is that going to end up in? 2, because it's between 90 and 180. I'm not going to get a protractor out and measure. I'm just going to kind of ballpark what I think 135 is. Now, some of you, that's all you draw for your angle. That's fine. I like to be dramatic and be like, hey, from here to here, I covered 135. Now, we need to evaluate cosine. So I need a triangle, sides of a triangle. We make our right triangle with the x-axis. The key is you need this very lovely little angle between the x-axis and where we ended up, our reference angle. So from 135 to 180, what's the difference? 45. So we have the 45, 45, 90. Now I can label my side. Before I write down the two sides that represent cosine, adjacent hypotenuse, one of the sides on the triangle needs a negative due to where you're located, the factor in quadrant 2. Now, this guy needs a negative because you're moving to the left. You're on the left side, the negative x-axis. One's positive. Hypotenuse always positive. Why is the hypotenuse always positive? Because if you do Pythagorean theorem and square these numbers, they're positive. All right. Cosine, of course, adjacent hypotenuse, adjacent to my reference angle, hypotenuse. Then I cringe just a little bit because, of course, we can't have that square root of 2 down there. I'm just going to do a quick rationalize and put a final answer in negative root 2 over 2. I am assuming you have done this last year. We're going to be doing it a lot over the next few days. Any questions on the first one? All right, tan of 300. So same thing, draw your angle. Now, again, yesterday, I was nitpicky and I said, I do want you to label the axes, da, 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 da. You don't have to be as carried away about it today. Like, for instance, we should know 300 is going to land in which quadrant? 4. So I'm just going to 90, 180, 270, 300's over here. And you know I like to label. I like to be dramatic. Okay, make your right triangle with the x-axis. And of course I need this reference angle. How many degrees are between 300 and to get to a full circle, 360? 60. Now I'm going to label the sides accordingly. So this would be your 30, of course, opposite the 31, opposite the 60 root 3, hypotenuse 2. And now before I actually write out the sides that represent tan, my left sides, which one of those sides on your triangle means a negative sign? Square root of 3, because you're on the negative y-axis portion. Okay, tan, TOA, opposite, adjacent. Who needs over 1? I'm just going to put my final answer, negative root 3. All right, let's do sine of 210. It's nothing but drawing triangles the next few days, I feel like. Okay. And again, I'm not picky about labeling the axes, just because too sometimes it gets kind of messy, all the stuff on the picture. So I'm at 90, 180, 210 is going to be over here in quadrant 3. I'm going to label. Now I'm going to make my right triangle, of course, with the x-axis. And we need to figure out our reference angle. You're always comparing to the x-axis. The x-axis is 180, we're at 210. What's the difference from 180 and 210? 30, yeah. And then I'm going to label the sides accordingly. Opposite the 31, opposite the 60's root 3, hypotenuse 2. Think about which sides need a negative. Question, gentlemen? Question? I just want to make sure. Okay. Which side or sides plural needs a negative? Yeah, both of them, because you're left down. All right, sine, opposite hypotenuse. We got it, opposite negative 1, hypotenuse 2. No rationalizing or anything else to do. Got it. So this is basically what we were doing the majority of the day. The only thing that's going to really get a little different, they might give you the angles in radians, or they might give you some very large angles. Now, just like yesterday, remember I drew that 7 pi and I was going around the circle multiple times, it gets really obnoxious. If you're over 360 or 2 pi radians, I would use a coterminal angle. I would subtract or add, let's put coterminal in here. I would add or subtract 360, whatever you need to do, or if you're in radians, 2 pi. Because remember, it's just a different route to end up at the same exact spot, but we want to work smarter, not harder. So if I'm over, like the next one, I don't want to draw 495. I would have to do a complete revolution plus some more, just to end up at the same spot. So I'm going to use a coterminal. I'm going to take 360 off. All right, what is 495 minus 360? 1, yeah. I much rather draw that. If you mark out 495, you'll get the same answer. You just have to go around a full circle plus some more. Why do all that work, right? So let's draw 135. And we're going to do cotan. We haven't done cotan yet. Okay, so we're rotating 90 and 135 is going to be over here. Just going to estimate it, of course. Make my right triangle with the x-axis. What is your reference angle? 30, 60, or 45? 45. 45 more to get to 180. Label your sides. Now, this bottom one, I'm going to throw a negative on because you're on the left side of the x-axis. Now, cotan, remember, is the reciprocal of tan. So I'm not going to do TOA. I'm going to flip it. I'm going to do adjacent over opposite. Adjacent over opposite. So adjacent negative 1, opposite 1. All that work for a lousy negative 1 answer, but hey, we got it. Jason, do you have a copy of the notes?
No.
They're on the table there in the corner. All right, secant 405. I can't say that I want to do really 405 because, again, you're over 360. So I'm just going to subtract that. So I don't have such a tough angle to draw. So what is 405 minus 360? 45. Well, that's a nice one. I like that. 45, super easy. You're just in quadrant 1. That's going to be easy to draw. So notice I didn't get crazy, you know, big picture here because 45, that's right in quadrant 1. Obviously, you're on your 45, 45, 90 triangle. We're in quadrant 1, so everything's positive, but we need secant. Secant's the reciprocal of cosine, so I'm going to do hypotenuse over opposite. Over adjacent, sorry, hypotenuse over adjacent. Hypotenuse root 2, adjacent 1. So did you do a lot of this last year? Does it seem familiar? Okay, good deal, good deal. So like I said, the only thing besides maybe being over 360 and having to subtract, I mean, that's not a big deal, is we might have some that are in radians, okay? So here's the deal with radians. I don't mind radians. You know I love a good fraction. You know how you feel about fractions. If you really, really hate the radians and the fractions and all that stuff, you could convert it into degrees and work on it that way. Do I care? No, I just care that you can get the right answer. So if you want to convert it into degrees, so look at the board over there, we're doing radians to degrees, the blue one, you could multiply by 180 over pi. Definitely going to need your calculator for this. I can reduce a little bit. 3 goes into 180 60 times, but I can't tell you in my head what 16 times 60 is. Seems large. Punch that in your calculator. What's 16 times 60? Okay, so I don't like 960. Who wants to draw 960? I do not. I do not. I would do a coterminal. Take 360 off of it. I don't even want to draw 600. Do you? Take another 360 off. What's 600 minus 360? Eric, you got it, 240. I'll do 240. So, again, you could draw 960 if you want. You could draw 600 if you want. I would, of course, get it down to something less than a full circle so it's not so obnoxious. I'm going to go 240. Okay, so 240, of course. So rotating 90, 180, 240 is going to be past that. I like to dramatically label. You do not have to. Make your right triangle with the x-axis, of course. Key is that reference angle. How many degrees are there between 180 and 240? 180 and 240. 60, yep. Okay. So this would be your 30. Opposite the 31, opposite the 60, root 3, hypotenuse 2. Now, just due to our location, the 1 needs a negative, so is your root 3. Then we're just doing sine. Opposite, hypotenuse. Negative root 3 over 2 for a final answer. Okay, I don't know if we need to do both B and C. I feel like it's getting repetitive. Yes, like it's very repetitive. Let's just, I don't know, let's do a negative one though. Let's do B. Okay, if you do not like the pi over 4, convert it into degrees. Or maybe, do you know what pi over 4 in radians equals in degrees off the cuff? What's pi over 2 in degrees? 90. This is half as much. So it's 45, negative 45. Just a little fraction work for you. If you need to convert it, convert it. So all the negative does is affect the direction you rotate. So instead of rotating up or counterclockwise, you're rotating clockwise or down. Now, when I label my angle, I'm not going to put negative 45 in there. The negative just affects your direction. I care that it's 45, that I'm on the 45, 45, 90. The negative just affected how you rotate it. And I just put my negative on this one because you're on the negative y-axis part. Okay, we need secant, which is the reciprocal of cosine. So I'm going to do hypotenuse over adjacent. So hypotenuse root 2, adjacent would be 1. Let's just put root 2 for a final answer. All right, do we need to do C, or is this, I didn't know how much you do with this in Algebra 2, so I didn't know how carried away to get with it. Okay, did a lot. All right, so the last thing I'm going to show you as far as the evaluating, and I'm going to show you one more thing on those identities today and some calculator stuff, is we need to talk about the 90, 180, 270, 360. You can't make a triangle out of that. You can't do hypotenuse over whatever. You have to use the points. So, to do your quadrantal angles, unit circle and points. I'm talking ordered pairs here. You're like, what do you mean points? And clearly we're going to draw this. Now, when you have the ordered pairs, x comma y, ordered pairs, x, y, the x coordinate represents the cosine. The y coordinate of the point represents the sine. An easy way to remember that, it's alphabetical, C, S, cosine, sine. Now, we're going to need tangent. Let me grab a yellow sheet. If you look on here, look under the second group, quotient identities. How can you define tangent with sine and cosine? Sine divided by cosine, so that's what we're going to use. Jason, I'm going to leave that one up for you. Okay, so sine over cosine. So the next thing we're going to do are some quadrantal angles. So notice I have this all on one slide, and I kind of on purpose left kind of some room over here because I'm going to draw one picture to answer all of these. Okay? Because notice 90, 270, 360, negative 90, they're all the quadrantals. So one picture is going to do it all. I see most of them are in degrees. I mean, that guy's pretty easy to convert into degrees. We'll deal with it. So I'm going to label in degrees. So 0, 90, 180, 270, and the full circle 360. Okay. And we are going to draw a circle. Now, to do these, of course, I'm just going to click it back a slide here quickly. We are going, it says to use the unit circle. If you remember from yesterday, unit circle is a circle with a radius of 1. So, oh gosh, here comes right now. I'm going to go up 1, right 1, down 1, left 1. And I'm going to attempt to draw a circle. It's not going to be pretty, kids. I can already tell it. It started off good, and then it kind of fell apart. Okay, all right. So we're going to use these points. Don't laugh at my circle. That's bad. That's very bad. We're going to use the points. Now, ordered pairs. Remember, radius of 1. So this point you went right 1. So that ordered pair would be 1, y would be 0. This ordered pair, x is 0, but we went up 1. Left point, we went left 1, y is 0 because you're on the x-axis. This ordered pair is 0, negative 1. Once you have all the points, I don't know what is happening. Now, remember, the points give you a lot of information because all the x coordinates are the cosine, all the y coordinates are the sine. And if I need, I'm going to bring it back, if I need tangent, I'm going to have to do sine divided by cosine. Big whoop, but I'm going to have to divide some stuff. Who cares? Okay. So once you have the picture, you can do all the quadrantals off it. So I'm doing sine of 180, first one. So I'm looking at 180. Sine is the y coordinate of that point. 0. Done. And you are going to get for these like 0, 1, negative 1, you're going to get the same answers a lot. Cos of 270. 270, cos is the first coordinate, 0. We're done. Tan of 360. Now, tan is where I'm going to have to do sine over cosine. 0 divided by 1. Well, what's 0 divided by anything? 0. Got it. Secant of 90. Now, we have cos and sine. I need secant. Look on your yellow sheet at the very top group. Remember those original fractions we did all the craziness? Secant is the same as 1 over cosine. That's under the reciprocal identities. So I'm like, okay, I got it. Cosine of 90, cos would be the first coordinate, 0. So I have 1 over 0. That's a little problem. What's 0 under the line? Undefined, yeah. Can't do it. Whatever. Okay, negative 90. That's really negative 90. Now, I don't have negative 90 marked on here. I didn't do the negative angles, but it's the same point as what? 270. Negative 90 is the same location as 270. Cosecant. I have cos and sine, so I'm going to use my reciprocal identity on my yellow sheet. Cosecant's the same as 1 over sine. So sine of this point at 270 is negative 1. We get negative 1. So the quadrantals, anytime you have 90, 180, 270, 360, you can do them all off this exact same picture. You do not have to keep redrawing it over and over and over again. It gets obnoxious. Okay, the last thing I have to show you is some more identities. This is on your sheet. This is the third group. So look for the third group. We're going to use those. Even and odd. Now, we've talked even and odd functions in the past. Even. Anytime you replace x, they're using t, with a negative x, simplify, blah, 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 you should get the exact same original function out. The rest of them are odd, which means you get the opposite. Notice they have all these negatives on it. Okay, so it's all about the positives and negatives. Easy, but here's what you got to remember. Cosine or even. So you do not change any positives or negatives. Cosine and secant, you write down the exact same fraction, you don't touch it. The rest of them, opposite, bless you. You're going to just be changing the sign on it. So it's all positive and negative work we're going to do. So use the value to find the rest. Okay, so cosine is even. So I don't even have to think about it. My even odd function, it's even, it's the exact same thing, I don't even change it. Hardly seems worth writing. Now, secant, even, but you gotta do a little bit of work to get secant. We're gonna keep the same sign, I'm not gonna change anything, but I need to do what to this fraction? Flip it. So secant's gonna be negative 4/3. That's all it is. There's no one, do I keep the sign or change the sign? Now, next one. This guy's odd. So mathematically that means you get the opposite. What is the opposite of 3/8? What is the opposite of positive 3/8? Negative. Now, I don't have cosecant written up here. I mean, I can write it for you. Cosecant would be 8/3, which is odd, so I need the opposite of positive 8/3. Yeah, negative 8/3. So there's no work to these, but you have to know a couple things. If it's odd, you have to change the positive negative part of it. And you might have to do the reciprocal if you need cosecant, secant, or maybe cotangent if they give you those. So it's a fraction flip and then positive negative change. Okay, last thing, some calculator stuff. Get your calculators out. Now, notice, says use your calculator, set it to radian. Eventually, they're going to have some degrees, some radians. Take a look at these. Do you see a degree symbol anywhere on the slide? Sure don't. That's why your mode's going to be in radians. So pull out your calculator. At the top it tells you mine's in radians. If you have to change it, hit your mode button, and you can see the fourth line down. Okay. So we are just literally typing these in our calculator, rounding to 4. So sine pi divided by 4. So I'm going to round that to 0.7071. All right. Cos -3. That seems easy enough. Cos -3. That one's kind of a pain to round, I feel like, because you got like that domino effect as you keep moving up a slot. I would just round that whole thing to -1. Make it easy. Let's go -1 for that. Okay, cos -1.7. Literally type it in. So let's round that to -0.1288. Okay, a little glitch here. Do you have a cosecant button? Doesn't mean we can't do it. We're going to use one of our identities on our yellow sheet. Cosecant is the same as 1 over sine. So I'm going to type in 1 divided by sine of 0.8. 1 minus sine 0.8. And then of course let's round to 4, so I'm going to put 1.39 over 0. Got it. Any questions on the calculator part? Nothing? Okay, so remember, homework is front and back, not umpteen pages like it was last night. And remember, Monday, no